All right, in number 3 here, we've got the graph of a function g given to us right here on the interval from -4 to 8. They're telling us now two linear pieces in a semicircle, just so we don't have to assume. And then we have an explicit definition of a function f of x, which is given to us in terms of g. So we're supposed to find f of 7 and f prime of 7. So since we have the explicit definition for f of x, to find f of 7, we're just putting a 7 in for all of our x's right here. So that'll be a 3 times a 7 plus an integral from 0 to 7 of g of t dt. Okay, easy part, 3 times 7, that's going to get us 21. Hard part now is to come up with the integral now from 0 to 7 of g of t dt. So we are looking for the region between this curve here, guys, the graph of g, and the x-axis starting at 0 and ending at 7. So what do we have here? In red, everybody, we have a semicircle that is located below the x-axis, and then in blue, we have a rectangle located above. So real quick here, guys, the area of that semicircle right there would be a half of pi r squared. Radius is 3, so pi r squared would be 9 pi. Half of that would be 9 pi over 2, or 4 pi, or 4.5 pi, whatever you want to do there. But remember, since it's below the x-axis, the value of this integral is actually negative. And then right here, the area of that rectangle is going to be 3. So let's put those two together now, and that's going to get us the value of this integral here of 3 minus 9 pi over 2. And then we'll simplify that as best we can, but there's not much you can do there. 24 minus a 9 pi over 2. And that's what we've got there for the value of f of 7. Now, f prime of 7, I believe, should actually be easier than that. So I probably should have written out here real quick somewhere that f prime of x, the general derivative, would be the derivative of 3x, which is just 3, and then plus, all right, here we go, the derivative of a definite integral. Sounds like we're going to use fundamental theorem of calc part 2. And this one's as good as it gets, guys. Constant on the bottom, x for the upper limit. So this just becomes now g of x, and that's what f prime is. So down here for f prime of 7, that's going to be a 3 plus g, that was supposed to be a g of 7. And since this is the graph of g, the value of g of 7, we would go right here to 7, and the value of this function there is 3. So that's going to be a 3 plus 3, and our answer there is going to be 6. So there is our value for f of 7. Here is our value for f prime of 7. Okay, and that takes care of part A. 2 points total right there, one for each of those two values. Okay, part B, find the value of x in the closed interval here from -4 to 3 at which f attains its maximum value. So where can a maximum occur? Endpoints right here, so we're going to have to check -4 and 3, but also critical points. So we need f prime of x, but I'm pretty sure we did that on the last problem right there, guys. F prime of x is 3 plus g of x. And we need to know where that derivative is either equal to 0 or undefined, but it is not undefined anywhere on the interval we're talking, so I can forget about that. Bringing the 3 to the other side means we need to know where g of x is equal to -3. So let's go back and look at this graph here, guys, and the value of -3 only occurs once on this function right here when x is equal to 3. So g of x will equal -3 at x equals 3. Now we kind of caught a break here because 3 happens to be one of the endpoints of this interval. If this, for example, had been x equals 2, that would now give us 3 spots. We had to test the value of f for a maximum. But as it is now, it can only occur at these two endpoints. So we need to know the value of f of -4, and then we need to know the value of f of 3, and from there we should be able to determine which one of them is a max. And unfortunately, yeah, I was a little bummed by this, that's not the value that we found here before. So back to the drawing board, guys. F of -4. Okay, so I've got to go back to this definition of the function right here. So it'd be 3x plus the integral from 0 to x. All right, so 3 times x, that's 3 times -4, plus an integral now, this is a little weird, from 0 to my x value, which is -4 of g of t dt. All right, so the 3 times negative 4 gives me negative 12, no problem there. But now I need the net area between the curve and the x-axis between 0 and negative 4. But since those limits are backwards, guys, we're going to have to reverse or change the sign of this number. So instead of a plus, I'm going to do a minus right here. And let's think then about the integral from negative 4 to 0. And this one isn't too hard to figure out, I don't think. From negative 4 to 0, we get this triangular region here with a base of 4 and a height of 2. So 1/2 times 4 times 2 is going to get us 4. It's above the x-axis, so it would be a positive 4 if not for the fact that the limits were different. So that ends up being a minus 4 right there. And negative 12 minus 4 is going to get us negative 16 for the value of f of negative 4. Now we've got to compare that to f of 3, which is going to be 3 times x, so 3 times 3, plus a definite integral from 0 to 3 of g of t dt. What's that going to do for us? 3 times 3 is 9, and now the integral from 0 to 3. I'm going to switch colors. I got too much blue going on here and a little bit of red. Let's go green here. So an integral from 0 to 3. So now we're just talking about this region right over here, which is a quarter of a circle located below the x-axis. So the area of the entire circle we said a while ago was going to be 9 pi. Half of that circle was 9 pi over 2. A quarter of the circle then, I don't know, area of a quarter circle. Sure, we'll go with that, is going to be a 9 pi over 4. Since we're below the x-axis, that will come out being negative in this case right here. So actually, let me get rid of that plus and make that a minus 9 pi over 4. So those were the only two spots here, guys, negative 4 and 3, where this maximum value could have occurred. We got negative 16 here. This one can be a little bit tough to see here, but I think we don't have to get too precise here. If I were to just let pi be roughly 3, 9 times 3 is about 27. 27 over 4 is in the neighborhood of, what, 6 1/4? It's less than 7. Okay, so we end up with something like 9 minus 6 or 9 minus 7. The point there is, guys, that's going to be in the neighborhood of 2. It's definitely going to be positive, is my point, though. So notice they weren't actually asking us for the maximum value. They want to know, find the value of x at which the function attains its maximum. So we should probably say right here that f of x reaches, or I could say attains, its maximum value on the interval here from negative 4 to 3, bracket, at x equals 3. Sometimes they ask you for the actual maximum or minimum value, and sometimes like this, they just ask you for where that occurs. So that's what was going on in part B. Okay, in C, 2 limit questions. So let's get working on this. The limit as x approaches 0 from the left of g prime of x. Okay, so as x approaches 0 from the left of g, that was g prime of x. Yeah, all right, guys. So this is the graph of g. I'm going to erase some of the junk that I've done right here. This is the graph of g, and we're talking about g prime, everybody, which, since I can't really just come up with a value for that, I suppose this one I could, we're really talking about the slope of a tangent line, or really the slope of a tangent ray. And as x approaches 0 from the left, the tangent ray would be the same as that function itself, and its slope there, if we just counted that off, down to right 4, the slope would be negative 1/2. That's the slope of that red tangent ray. That's the answer to my question right here. The limit as x approaches 0 from the left of the derivative of g is negative 1/2. Now this next question I found really interesting. Limit as x approaches 0 from the right of g prime of x. So when I went back to the graph here, I said, okay, now we're approaching this same value here of 0, but from the right and moving back to the left. So I got to thinking about the slopes of tangent rays at a couple of different points right here that were to the right of 0 and now are moving back to the left. And this slope right here, I don't know, looks like it's maybe negative 1/2. This slope right here, maybe negative 1. This slope, maybe negative 2. And as we keep inching back closer and closer to this point, I reasoned then that the tangent line was actually going to run vertically at that point. That my slopes were going, what did I just say, negative 1/2, and then negative 1, and then negative 2, but that they were going to keep decreasing without bound until we ended up with a vertical tangent right there passing through the origin. And so for that reason, I answered this question negative infinity. A vertical tangent line would have a slope of either positive or negative infinity, but because we were dealing with negative values as we got close to 0 from the right, that's why I said negative infinity. Now, as I'm looking at their scoring standards, they say that the answer right here is DNE, does not exist. So, I was a little torn on this one right here. I obviously feel, and I think I've got reasons for it, that negative infinity is the right answer. The book said the graders said does not exist. When I graded your practice test, I gave credit for either one of those answers. I certainly wasn't going to take off for this one, even though I feel like that's not quite accurate to say. A limit not existing generally implies that your y values are not approaching a set value, and I felt that they were here. It was just an infinite value rather than a finite. So I'm good with either one of those. All right, and on D here, find a limit as x approaches negative 2 of this mess right here. As soon as I see a limit question on a free response portion, I thought it was going to be L'Hopital's. Now, whether I'm right or whether I'm wrong, and I've been wrong on this lately a decent amount, you still have to do the same thing first. You plug and chug, and you see if that works. So this would become f of negative 2 plus 7 up on the top, all over e to the, let's think about this, 3 times negative 2 is negative 6 plus 6. Okay, that's e to the 0, and then a minus 1. And what does that do for us? We need the value of f of negative 2, and this one was a little bit of a pain right here. F of negative 2, that's a whole bunch of work I got to do here again. So, all right, guys, so it's 3 times negative 2. Let me do this down here. F of negative 2 would be 3 times negative 2 plus the integral from 0 to negative 2 of g of x dx. So that's a negative 6. And now the integral from 0 to negative 2. So we're talking about this region that I'm shading right there, guys. So what is it? Triangle, base of 2, height of 1. So the area of that triangle is going to be 1. It's above the x-axis, so it would be positive. However, the limits of integration yet again are backwards, so that should be a negative 1. So f of negative 2 ends up equaling a negative 7. And then I felt pretty good when I came up with that answer, because that means that my numerator now is negative 7 plus 7, which of course is going to get me 0 in just a second. In the denominator, e to the 0 is 1 minus 1, and sure enough, we end up with 0 over 0, and that's the clue here, guys, that it is okay to go ahead and use L'Hopital's rule. However, we've said this many, many times, you will not get full credit here, guys, from the AP graders on a free response question if you just dive right into L'Hopital's rule without showing them that you tried it and you got 0 over 0 or infinity over infinity or one of the other indeterminate forms. So now that we have shown that, though, that shows that this limit right here is equivalent to the limit as x approaches negative 2 of the derivative of your numerator divided by the derivative of your denominator. So the derivative of f of x is just going to be f prime of x, and the derivative of that 7 is just 0. Derivative of e to a power is going to be the same base to the same power, and then times the derivative of that exponent, which puts a 3 out in front. And again, the derivative of that minus 1 is 0, and we can forget that too. Okay, so what happens now? Actually, f prime of 2 is a lot easier. Again, we said a while ago right here that f prime of x was going to be, the derivative of 3x was just 3, and then plus g of x, and that's all we had there. So f prime of negative 2 we're plugging in here is going to be a 3 plus g of negative 2. Okay, we'll work on that in just a second. And then on the bottom here, we have 3 times, and again, this becomes e to the 0 power. Okay, I need the value of g of negative 2. This is the graph of g, and at negative 2 right there, my y value is 1. So g of negative 2 is equal to 1. That's a 3 plus 1. All over a 3 multiplied by a 1 is going to give us a 4 in the numerator and a 3 in the denominator. And that's the answer we were looking for here for problem. This was number 3D. All right, guys, so that's a wrap on everything in problem number 3.